Welcome and thank you for joining us for the first Agro Lunch and Learn webinar of 2021, folks. This webinar series is only possible through the generous support from Eurofin's Agroscience Services, and we want to thank them very much for their continuing sponsorship. My name is Solito Sumulong, the president of the ISAA Agrochemical Network and from Provivi. I'll be serving as a moderator for today's webinar. Attendees will be able to submit their questions and comments for the speakers via the Q&A tool, preferably, and that would be throughout the presentation. All questions will be answered at the end of the presentations. So today's webinar was planned cooperatively with the ISAA Agrochemical Network, the organizing entity of the International Symposium on Adjuvants for Agrochemicals. And it's now rescheduled for April 25 to 29 in 2022. ISAA recently announced changes that'll bring you the ability to connect to your professional colleagues year-round and fulfill the very real need for a professional connection. And that's been brought on by the pandemic. Our website will be filled with engaging resources for $20 per year and attract professionals with keen interest in novel agrochemical formulation and design, such as webinars like this one on our own, and electronic access to previous symposia papers, especially we'll be talking about the 2022 symposium in Bordeaux. So before I introduce our speakers, I'll take a moment to highlight the benefits on becoming an Agro member. Agro pays enormous benefits by enhancing your science, building your scientific network, and supporting your professional development. So please go to the Agro website at agrodiv.org and click on Become a Member. The cost is less than $20 a year, and you do not have to be a member of the American Chemical Society to join as an affiliate member. I'd also like to remind you about the upcoming ACS Fall National Meeting in Atlanta this August. While the conference will be hybrid, all Agro programming will be virtual. The preliminary technical program will be soon available, so keep an eye on your email and the website for that announcement, and contact Xing Li if you have any questions. Keep in mind that more webinars will be coming this year. Steve Duke will be up next on July 21st. He will be presenting new herbicide modes of action for commercial herbicides, searching for the Holy Grail. This is guaranteed to be an entertaining and fascinating webinar. You can register on the Agro website, and you'll receive an email with the registration link after this presentation. On September 22nd, Dana Vogel from US EPA will be presenting 50 years of history at EPA, which should be an interesting retrospective highlighting the accomplishments of the EPA Office of Pesticide Programs. Now, I'm proud to introduce our two speakers today. Elodie Shaw is a business development manager at Stepan Europe, where she explores adjacent and new market segments for Stepan surfactant business unit. Prior to this role, Elodie was part of Stepan Europe R&D for 8 years, developing solutions for an evolving agricultural market. Renaud Perrin is a formulation specialist in agrochemicals with a focus on organic markets, starting with Stepan a mere week before the French COVID lockdown. Previously, he worked for Syngenta's Formulation Technology Group and conducted research on performance improvement through physicochemical loss mechanisms and efficacy booster adjuvants, and they are both based out of Grenoble, France. So we now welcome Dr. Shaw to start the journey from plant protection to plant health. Bonsoir, Elodie.
Hello, thank you. Yeah, here, both me and Renaud are based in Grenoble, and just right now a big thunderstorm has just started. So we hope we're gonna be with you until the end, and there won't be too much noise in the background. So I will just start and share my slides. All right. So thanks for attending this webinar. Thanks for the introduction, Solito, and for his invitation. So today we want, with Renaud, we want to walk you through our journey from plant protection to plant health. And really, we wanted to share our own observations on the opportunities and challenges of formulating with biological actives. So first of all, just a bit of semantics, really to ground us all. The widely accepted definition of a biological active in agriculture is a naturally occurring product. And typically it is segmented per function in the market. So biofertilizer, biostimulant, biocontrol product. Starting from the right-hand side, biocontrol products, also biopesticides. I think everybody knows what this means. Biofertilizer might be slightly more obscure in terms of definitions. Biofertilizer is not an organic fertilizer like manure. Biofertilizer really describe microbes that boost the availability of the soil nutrients to the plant. They're also called inoculum or rhizobium. And finally, the last category in the middle, biostimulants. They are not nutrition products. They're really a product that stimulate plant natural processes to improve nutrition or to improve tolerance to abiotic stress. They also can help with crop quality and yield. So first of all, I wanted to start with maybe for some of you debunk a myth that biological active doesn't equate organic farming. I think it's even more complicated in some of Latin languages where organic actually farming is use the term biology farming. So that makes things really confusing. I've tried to sort of categorize which actives are used in which categories, and it is different region per region, but mainly organic farming prohibit the use of synthetic pesticide and favor the use of biological ingredient. For fertilizers, slightly more complex. So inorganic fertilizer, so NPK, nitrogen, phosphate, and potassium fertilizers are not allowed in Europe in organic farming. Some sources, as understood, are allowed in the US, so it's a bit more complex. With the organic fertilizer are also preferred. But one interesting thing, and I got that figures from Dunham Trimmer, is actually when you look just at the biocontrol markets, so biopesticide value, only 10% of that is attributed to organic farming. So really the markets that's driving and the trends that's driving the adoption of those products is really driven by conventional farming and not so much organic. And so now I said the word, so it's all about what's driving the adoption, why switching, or why the biological actives are serving a purpose in the way we grow food. First of all, it's really driven originally by consumer preferences. So the scare of toxic residues in fruit and veg, concern about health, are really driven the adoption of biological pesticide into especially in the fruit and veg segment. And this was really supported also by major food manufacturers or supermarket grocers that also really push this trend. And overall, we see that fitting into a sort of a chemophobia that we see in other markets we operate in, where people, kind of think, okay, natural products is always safer than synthetic product. Obviously, being chemists, we know that's not the case, but that's really ingrained in public perception. Biodiversity and soil preservation, those words are on everybody's lips now. Whether you sell a shampoo or a barrel of oil, you will see in the 2030 sustainability objectives, it's all about, preserving those two areas. And this may be slightly more recent than what described earlier about preserving health. It's more preserving the environment and the concern and the impact of agricultural practices. And here, there's some mixed messages. So obviously, we know producing food in certain ways can actually lead to more CO2. If you some use of some product can really help with that. At the same time, I think it's fair to say that the use of biological active, by and large, are much more. How would I say that? I think I need to choose my words carefully there. I think in terms of protection of soil and biodiversity, by and large, are probably a bit safer. Some of them even participate to really the regeneration of the soil. Regulatory pressure. Obviously, me and Renaud, we see in Europe, and we see that every day. So not only, obviously, regulatory pressure on actives that's disappearing every year, and then creates an aspiration for new solutions. But also what we're saying from where we're sitting is really pressures also on coformulants and adjuvants. So obviously, Europe banned nonylphenol and ethoxylate a while back, and recently we have a wave also of new regulations. So the coformulant ban list as part of the Annex 3 of the Plant Protection Product Registration, which was enforced in March this year. We also have the microplastics regulation that's coming, that's putting a lot of scrutiny on some persistent polymer used in agriculture. And soon we will have the registration of polymers within REACH. And really this creates a lot of regulatory burden in what we do, and to be honest, seldomly create opportunity for innovation, unfortunately. And the final one is political mandate. So again, this is very predominant in Europe. You've all seen, I'm sure, and read about the Farm to Fork initiative as part of the new EU Green Deal. And the objectives are pretty ambitious. So by 2030, halving the amount of synthetic pesticide, decreasing by 20% the amount of inorganic fertilizer, increasing by 25% land with organic farming practices. So all of those drivers you see, they're here to stay. They're really pushing for a stronger adoption of biologicals. And that's why we think, this market is not an epiphenomena, it's not a niche. It's really gonna be something that's gonna be very predominant in the way we agriculture is practiced in the near future. And just to look at some figures again, thanks from Denham Trimmer, some 2018 biocontrol figures. So that market biopesticide equates about $3 or $4 billion a year, which is roughly less than 10% of the overall pesticide market. The leader is actually US and Canada, and we think this has really been favored by a more simple and easier registration of biological biopesticide active favored by the EPA. The fastest adopter is actually LATAM, and here, obviously, there's strong pest pressures. There's some issues in some areas of soil poverty. There's also a wide area of biodiversity to preserve. So all those criteria also pushing the adoption of those products in LATAM. Finally, before I leave the floor to Renaud, I wanted to say also this trend of we talked about biological actives, so naturally occurring product, but we see also an accompanying trend, which is the derivation of natural product into other products, so inspiration from nature. And so whether it's designed synthetically or fermented maybe, and then tweaked to improve stability. There are a lot of actives and successful actives that are being launched on the market. And what we see is really a move from small molecules to larger molecules. And this has a big implication in formulation, as we will see. So some example of that, I've got a molecule of abamectin there. Spinosate, obviously, is another example. The new product from Corteva, the fenpicoxamate, also in that vein. And really, if we compare to pharma, there was a similar movement 10, 15 years ago. And now today, if we look at the drugs on the market, about half of them are actually natural derived. And so we expect to see a similar move in ag. And this means actually will have strong implication in terms of how we formulate product.
Thank you, Elodie, and hello, everybody. So I'll be focusing here on the formulation challenges. So as you can see from the pictures, there are many. So to start with, they're sensitive, they're new actives with unusual physical chemistry and variable quality. So, you know, they can be living organisms, spores, proteins, or parts of living cells, or extracts. So that brings a host of formulation challenges. So you can see the picture on the top left here. This was an attempt at milling. So this should be liquid. And as you can see, it made more of a cake. And to illustrate the variable quality, this is the picture to the right. This was a suspension concentrate formulation. So the one on the left was a formulation I developed that was stable. And then I made a second batch with a different batch of active ingredients. And as you can see, it's not so liquid anymore. It looks more like a thick gel, a thick goo. So it's quite difficult to reach conventional formulation standards. So here we've got the example of viscosity, but then also reducing particle size, keeping things stable. There are many formulation challenges around this. Difficult to get, you know, something that will be as good as a conventional formulation. We also have limited formulation types. So for example, suspension concentrates, oil dispersions, which is the same thing, but where particles are suspended in oil, and then solid formulations like wettable powders, wettable granules. So that means there's not only are the actives more difficult to formulate, but there's less formulation options. Also, we've got really Christmas list requests from customers in terms of coformulants. So they would like coformulants to be biodegradable, renewable, bio-based, mild, with no hazard classifications, unrelisted, REACH registered, REACH compliant, everything. And on top of all that, cheap. So obviously these are complicated requests. It's complicated to tick all of the boxes. And clearly right now we have a lack of coformulants designed for biologicals. So all of this makes it quite challenging for formulators. Now, if we put ourselves also in the shoes of retailers, it's quite complicated for them to sell such products, biologicals, because they're not only are they less efficacious usually, but they're also more expensive than conventionals. And as you can see from that picture above, there are, how can we put that? There are more failure modes with all these formulations. So these are all formulations with the same active ingredients. And as you can see, that all of them got, you know, issues with dephasing and whatnot. So that makes it very difficult for them to sell. And really what we need is to reach the same price as conventionals. I didn't want to say chemicals because, you know, it's not like chemicals are necessarily bad, right? So we need to reach the same price per hectare in terms of treatment, you know, what the farmer will spend. Because currently we've got a market where it's still a bit niche. And so the prices are much higher. And this is really hindering wide market adoption. And then if we put ourselves in the shoes of growers, well, if we look at the picture on the middle there, this is a typical example of a nozzle filter that's clogged because of, you know, poor formulation quality. And so if you have application issues like this, the farmer is going to try once or twice, and then after that, you know, they won't try again. You know, why would they use this product, which is more expensive, more difficult to use when they can just simply go back to chemicals. I mean, conventionals. Next slide, please, Elodie. But now, probably we can turn some of these challenges into opportunities. So most of you are probably familiar with the loss mechanisms of active ingredients. So things such as volatile loss, rainwashing, spray drift, chemical degradation, all these things that can negatively affect the efficacy of your product. Now, biologicals, they weren't designed, so to speak, to be efficient and to resist all of these things. So conventional actives, they've been improved to be resistant, whereas biologicals are not. So these loss mechanisms are more prominent there, and they need to be identified and quantified. So here there's a real opportunity for CROs. For example, need to develop new test methods and also improve existing methods. For example, currently for a penetration test, that would generate, from the method I know, that would generate about 200 to 400 HPLC samples. So if a CRO charges me $100 per sample, obviously that makes the test extremely expensive. So that's just a no-go, especially for small companies. So there's really room for improvement there. And once these mechanisms have been identified, they need to be mitigated. And that's where the opportunity for formulators lie. So there can be a lot of formulation solution and delivery technology to try and reduce all of these loss mechanisms. Also, something we've identified is that because the biologicals are not only more sensitive, but also usually more difficult to produce and more expensive, really there needs to be a shift in strategy from late defense, as it usually happens with conventional, to early optimization. So defense was usually at the end of the patent life of an active, where you think, okay, it's going to be off patent soon, so I need to make a better formulation, I need to make it more efficient, and then a patent will, will give me more, will guarantee revenues in the future. Whereas there for biologicals, we need to do that straight away to try and match the efficacy and the price of conventionals. So there really needs to be a shift there. Next slide, please, Elodie. Now, some of the things we can do to improve this. So there can be formulation technology and adjuvants, for example, to improve viability. So here we've got a classic example on the leaf, with and without a spreading adjuvant. Obviously here the spray pattern on the right leaf is going to be much better. The distribution of the active ingredient and the coverage is going to be a lot better than on the left. And the picture on the left, you can see surfactant vesicles, a multilaminar vesicles, which is one of our technologies that can also help with the stability of the formulas. There's also an opportunity for formulators with existing know-how. For example, white biotech. So people who already know how to formulate yeast, for example, they could definitely enter the market, and they've got they've got a part to play there. Also, there could be some old or niche formulation types that may come back into fashion. For example, there could be dustable powders, granules, pellets, tablets, rodlets, etc. Maybe ultra low volume, or the defunct Electrodyne, for those who know. Because also, let's face it, the current technology is rudimentary. I mean, I wrote rudimentary, but really, you could even say it's primitive. We're basically drenching fields with chemicals, whereas, perhaps with a more targeted delivery, we could reach, better results and also lift all the environmental issues that we have. So a few examples there. For example, we've got this bee vectoring technology where the bees are actually walking into the product and delivering it to the flowers. Of course, there's drone application. Also, the keen eye will see that there's something missing there on this tractor. So there's room for all of the automation that you could imagine, and precision analytics, seeding, harvesting, everything. And also other things like tree injections. So all of these application technologies will definitely support the formulation, because formulation alone, we can solve all the issues if the application technology stays the same. And also that means there's opportunities for specific new formulation types to be developed. And perhaps one question would be also, how do we maintain our business model if the volumes applied go down? If we go from massive amounts to ultra low volumes, then, if obviously you sell a lot less. So that's an open question right there. And over to you, Elodie, for the regulatory part.
Yeah, great. Regulatory and certification. So Renaud and I will walk you through a couple of slides of what we see on both sides of the Atlantic. In Europe, there is a new organic agriculture regulation coming up next year in a few months. And looking at co-formulant, because obviously that's what we do, and adjuvants, it's pretty clearly explicitly said here that all the co-formulant adjuvant using plant protection product would be authorized in this new regulation, as long as they authorized in PPP, as I said, so not part of this ban list in the Annex 3. However, later in the document, it does say one guiding principle of organic farming is to limit the use of non-renewable resources and external inputs to a minimum. And this kind of creates, I guess, a sort of gray zone for certification bodies and evaluation bodies in terms of what are they considering to be allowed in organic farming, according to them, to put their stamp on the bottle. And today in Europe, for what we know to date, co-formulant cannot be certified with an organic farming label, only end products. But co-formula are being scrutinized. Some of the attributes they're looking at are indeed the classifications, the ecotoxicity, also the type of feedstock, right? So back to the guiding principle of organic farming being looked at. Problem we've got is that there's no negative list, there's no positive list, there's no rules of what's acceptable and what not. And so as Renaud just said, we do end up with Christmas, wish list of trying to find best formulation pathways with really toolbox of co-formulant that just don't exist. And so it's kind of a bit of a cry, I guess, for help there, and want to share our what we see and some of the conundrum we're facing with trying to tick all those boxes.
Thanks, Elodie. And just to comment on the previous slide, there's also perhaps a bit of education that needs to be done with customers, because customers very often ask us for, oh, is your product OMRI listed or not? So that we can answer because there's a positive list. But for EcoCert, for example, because there's already an EcoCert for cosmetics and for other things, they're used to see this stamp for every ingredient. And so every time they ask us, oh, is your product EcoCert certified? And we're like, no, because it can't, because nothing can be EcoCert certified for agrochemicals in terms of ingredients. So it's, there's a lot of uncertainty around all this. Now, for the US organic farming, so there's a distinction that has to be made between regulations and labels. So you've got the USDA organic that supervises all the organic food, how it's produced and how it's sold. So you have to follow a number of guidelines around, organic farming, which are, some of them are pretty similar to Europe. And there's the added bonus, perhaps, that you have to produce your products using allowed substances. So that means there are some positive lists. And products also, labeling is also overseen by one of the 75 authorized certifying agents. So here we've put a selected few just to give you a bit of an overview of the variety of organizations that do that. So some of them are US government agencies, some of them are certification or auditing companies, some of them are not non-profits, some of them are based in the US, others are based abroad. So this is really a mix and match, and some of them may add their stamp to the packaging, but others not. So that's why you could see on top of the USDA organic label, there could be a wide variety of other labels, and it could be made from organic, 100% organic. There's a whole array of things you can put on your bottle, on your final product. And then there are the materials review organizations. So most of you are probably familiar with OMRI, but there's also a couple more which are government-based. So they review and approve all the coformulants in formulated products that can be used in organic farming. So that means basically all the inputs that a grower or a gardener can buy. And that's the OMRI stamp is very, very sought after by customers. That's something we hear a lot. But for us, that just they add some extra auditing steps, and they reduce the number of ingredients available. So really, they're good for end users. That's a stamp you can look for. But for formulators, it's complicated. So how that works? So the National Organic Program bases their lists on the EPA lists 4A and 4B. So that's basically list with a bunch of cast numbers and molecule names. On top of that, there's a petition system. So you can ask for new synthetics to be approved, which is systematically dismissed because they're synthetics, and because that's the way regulation is made. So for example, I saw in the petitions the example of sorbic acid. So reviewers say, okay, it's a synthetic, even though it is actually found in nature, but it is synthetically made, therefore it should be not allowed. And also in terms of, because this is a preservative, so in terms of preservation, there are already some options such as lactic acid or acetic acid, and that is sufficient for preservation. Therefore, this petition doesn't need to be approved. So yeah, that makes things a bit complicated. And also removal of existing synthetic products can be approved. So some smart people have noticed that they could use that to their advantage, to put it nicely. For example, on glycerin, because glycerin is synthetically made, because you hydrolyze fats to make it. And they said, wait, I produce glycerin by fermentation, and I've got the capacity to produce for the whole market. Therefore, we should ban synthetic glycerin, and that's been approved. So yeah, it's, how to put it nicely, the way things are done and reviewed, it's really not to anyone's advantage, really. Also, yeah, that makes it complicated because there's been hardly any new materials added since 2004. So, that's 15 years. And there is no clear list in one single place with clear statuses. So you can find EPA lists 4A and 4B, but that doesn't mean that some of the products haven't been dismissed later. So for example, I'm still not clear, are parabens allowed on NOP? I don't know. Or what exactly are the restrictions on potassium sorbate? I don't know, because it's really, an information that hasn't been made really easy to find. So perhaps there could be some inspiration maybe on what the EPA has done with their inert finder. That would be very helpful. And then there's OMRI. So how that works. So for a product to be registered on OMRI, you have to, prior to be approved already on the NOP list. And then OMRI will do the certification, which basically consists of the individual producers of ingredients will do the registration. So that means each ingredient has to be certified for each supplier. So that really funnels down the number of coformulants available to from a reasonable number to really only a handful. So for example, there are almost no preservatives available, and I think there's 2 solvents on the list. So, you know, that's a bit, that's a little bit complicated to work with. And so currently it doesn't seem to be possible to register new synthetic products. And we've got a huge lack of solutions, you know, in both systems. So how could we manage to improve that? So perhaps, well, already some suppliers like us could try to register more things on OMRI, but then how do we do to innovate when the lists have been frozen so many years ago? You know, how do we bring new technologies, new coformulants to market? That's an open question.
And so with this, some concluding remark, and maybe on a more positive note, we do see obviously the biological markets growing and growing, and see that trends continuing, and then a much more wider adoption, as we say, both in conventional and in organic farming of biological solutions. But as we saw, formulating biological is complex, but it is essential to deliver performance. And here we really think we can, as Renaud put it, turn challenge into opportunities, make the product more performant, and then therefore make them cheaper and more widely accepted. And really for that, I think Renaud built a very strong case there, but clarity on authorized coformulant for organic farming really help us. Could really help us drive positively product performance. Even I would even dare to ask harmonized coformulant in different regions. We know our customers, they want to roll out their solution in different parts of the globe, and you know, when I look at NOP list and the Annex 3 in Europe, there's some issues there, because there's some product that are banned in Europe that are authorized in organic farm in the US, and so those are the kind of things we have to obviously solve, and really hope that we use that tribune to sort of share that with you, and maybe, you know, trigger some thinking, some discussions with some of you today. And that's it. We want to thank you for your attention, and now we got some time for questions, I guess.
Thank you.
Great. We've had some questions roll in, Elodie and Renaud. I guess we can lead off with a few here. The first one that rolled in was and it was intriguing that you had that slide, Renaud, on the defense versus optimization, and setting up the laboratory work for that. So I think this goes well with that. What do you see as the major research gap which could facilitate easier regulation of biologicals in Europe?
You want to take that, Elodie?
Can you say it again? What do you see as
the major research gap that could facilitate the regulation of biologicals?
I mean, if it's a research gap, for me, well, the way I see approaching a sustainability question, it's about, you know, iterative steps and improvement. We could make great, you know, wettable powders. Biological product would be really efficient, dispersed very nicely. You know, some of some of the products that we could use for that, to do that, would even not be classified towards an ECLP, but would be banned because today, some of those feedstock are only available petrol-based. And, we're not saying, we don't want to strive towards a different chemistry. We're just saying we need some iterative steps. So I think what we would need is really an understanding of, what products should look like for growers to adopt it, and what are the solutions out there, and try to progress that iteratively, instead of having a dogma saying it has to be renewable for the solution to be accepted.
Okay, right. A question from Neil Bird would be, what do you see as the potential areas of future innovation in the area of co-formulants for biologicals in this case? I know you've mentioned some of the difficulties in formulation in terms of in-can performance and in the spray tank performance. But what do you see as those potential areas of innovation?
Well, probably there's a lot of work that can be done in terms of dispersants, for example. Co-formulants probably that are more tolerant to changes in quality of the active ingredient. So maybe, I don't know, maybe that could be blends or, polymers with more functionalities. It could be things like this. There could be a lot done on delivery technology, because usually, if these actives are sensitive, if you try to use a protein, for example, that's not very stable, and to acids and bases, that's not very stable to UV light. And how do you deliver that? How do you make a protein go from your spray to inside of the leaf? So that's, there's a number of challenges like this, and there's perhaps also technologies around encapsulation. There's a lot that needs to be done, and I think a lot of these technologies are not necessarily new, and probably the bigger companies already know them and have already looked at them. But usually, what I've seen is that these things get looked at, and then, well, it's too expensive or it's not scalable. So, yeah, how we do this, I think there's a lot that needs to be done, with perhaps new startup companies and academics to really develop these things to make them really viable. And I think we've got a real opportunity here with biologicals, because they start off, they're much more in need of these technologies. And the market needs to shift to the biologicals. Then I think that can now happen, exploring these new improved delivery technologies.
Couple of questions have rolled in, and conceptually they seem actually on the opposite sides of the extremes. There was a question that rolled in about how you would attack the question on biodegradability of co-formulants, and then there was also a question about the need for organic or green preservatives in a formulation. So obviously those two outcomes are quite different. How are you attacking those questions?
I can start by biodegradability if you want. For sure, we need to characterize, understand our product fate. I think for many years probably co-formulant got it easy in ag. We put those products in the soil and we did not know their fate in the soil and in different water streams. And so here, we need to take our responsibility and really, generate the data, and we are doing this, and obviously this will drive new solutions. We're seeing a lot of natural product or naturally derived product from biofeedstock that are very persistent in different environmental compartment. And that's an issue because obviously then you have the conversation about, biofeedstock versus biodegradability. It's not because it comes from nature that it's biodegradable, and especially not when you sulfonate it and you put it in water and when it's not supposed to be. So that's, those are complex questions, and that's where we think we need, better conversation to really strive for the best, safer co-formulant and adjuvants. And I'll let Renaud talk about preservation, maybe.
Yes. So preservation, that's really a big topic for me, and that's it's something where there's really a huge gap. So, ladies and gentlemen, if you're making preservatives, if you could make an OMRI listed preservative, please do, because it's currently there's basically nothing. So I think there can be natural preservatives, there can be natural extracts. The issue with NOP is that, the lists are frozen. So the only way to include that sort of ingredient would be to extract it from plants instead of synthesizing it. So you could think about, using essential oils, for example. The problem with that is, like, are essential oils more greener than petroleum chemistry? I don't know, because, to make a liter of essential oil, you need to use, tons of fresh leaves or, plants. So it's, it's not that well, that easy to define, and also that would drive the price up like crazy. So, for example, in NOP, the easy thing would be to just for the panelists who do the review, and from reading the petitions, they're like 3 or 4 people, which it sounds a bit small and not necessarily chemists. So they should maybe accept that new synthetics need to be put on the market, and they don't have to be really bad chemicals. They could be things like sorbic acid, for example, that I mentioned earlier. That's naturally found in plants. I guess why this is not used currently is that probably the extract is going to be too expensive to make, and also that's the kind of preservative where you need to have a low pH to work, something like 5.5. And this is not necessarily very compatible with biologicals, that are fragile, and not necessarily compatible with coformulants. So, yeah, there are some solutions there, and that there are lots of alternatives in terms of preservation, and that we can see in the cosmetics sector. Obviously, we don't want to use, like the more the worst ones, like isothiosolinones, things like that. But there are other things that are, synthetically made, but that doesn't mean it's bad. And we could definitely use these. Currently, I don't know how I'm going to preserve my formulations. That's where I am, basically.
We have time for 3 more, and I'm going to bunch a few of these. First, a quick clarification from Mark Shen on the chat. I just wanted to ascertain, did we say that only 2 solvents are OMRI listed, and what are those? And
that's my current understanding of the OMRI list. Yes, that's ethyl lactate and butyl lactate. Why these 2? It's because they are on the NOP list, so on the EPA list for A4B, and because a supplier, the biggest supplier of these things, has registered them on OMRI. And then there may be a couple more things like ethyl or methyl esters that you could use as solvents, even though they're pretty bad. But yeah, currently that's 2 solvents, and there's probably not enough coformulants to properly emulsify them. So yeah, it's currently making ECs that would be OMRI registered is, I think, not possible.
And parabens, what segments are they not allowed as a preservative?
Well, I wonder if they are actually allowed on the NOP list, because the OMRI website says that NOP has banned them, but I really couldn't find anything on the NOP website. because they don't have a nice tool to search all the information. So basically there's one page for each letter of the alphabet for all the petitions, and you've got to find there, is there a petition on that ingredient? And then when there is, you have to click on it and read the whole thing and see, whether they've made a positive or a negative decision about the ingredient. And that's not very clear. So you really have to look at the fine print. So right now, I don't know. They may be approved. They may not be. I don't know.
Okay. A couple of questions in the Q&A. Do you support customers to get OMRI or other certification in their formulations? And does Stepan have a list of OMRI certified products that could be used for organic farming formulation developments?
Yes, we do. We're in process of registering our products. That's an easy one. So yes, when our co-formulant are registered, then the customers that use our co-formulant for their own registration could benefit from that for their own registration for their own product.
Okay. So that should happen sometime this year, in a few months probably. There's about 12 or 13 products we'll roll out to start with, and then we could add more if there's interest.
And as for the encouragement part, do you encourage your clients to formulate for organic necessarily?
Well, not necessarily. No, I mean, it's currently formulating for OMRI seems so complicated to me. I wouldn't recommend it to anyone, really. But no, jokes apart, it's that depends on what the customers want. Also, perhaps looking at the first slides at the beginning of the slideshow, there could be some. There's it's not necessarily a need to be OMRI registered, because your biological product will be bought mostly by conventional farming.
Right. A couple of other questions I'm going to bunch together. There's one on why does the market need to shift to biologicals, okay? And there's another one from Prashesh Sharma about Latin America being the fastest adopters, right? So what are we learning from Latin America that can give us some insights about how to formulate, how we can accept formulations of biologicals and co-formulants and full formulations of biologicals?
It's a good question. We're both sitting in Europe, and this is kind of a tricky one for us. I'm not sure I see the link. The fact that a faster adopter doesn't necessarily mean they have solved the issues of how to formulate, and then the product they use look better there than in other parts of the globe. I think they're just in need strongly of products, any product really, to face the challenge they are seeing in the agriculture. So I think that's just the main reason why the fasting adopter. I'm not sure they found any trick in formulating better than other regions, and if they have, please let us know.
Okay, one more question. I'm gonna bunch two more together here from the question and answer panel. What are your insights on regulations for strain variants? And you have shown that different AIs in the same vein seem to have interesting physicochemical interactions with co-formulants. Can you give us some insight on the controlling of strain variants, for example, and other reactions that are occurring that would cause differences in the product viscosity or physical structure?
That's a very good question. Really, how to control strain variants, that's definitely the job of the people producing the active ingredients. I think maybe it will be difficult to really control and make sure that your product is always consistent, especially if you've got a microorganism or what I was formulating, which was a killed microorganism. So all the whole content of the cells a soup with everything. So obviously between one batch and the next, you don't know what the composition is going to be. So perhaps it's not so much about controlling your source, because I don't know, maybe you can't. That really I don't know. But perhaps you can you can have a watch out, and you can make sure that your formulation is robust enough that it will always be consistently performing, because you can't redevelop the formulation for every new batch. You could make some adjustments, but you need to be able to produce and get the product to market. So really, yeah, just try different batches and hope for the best. I guess that's the best I can do for you.
Thank you. Well, we are getting to the top of the hour. Thank you very much for the audience's participation in this webinar. Thank you to Kyle Sawyer, before I forget, our premier webinars host, Elodie and Renaud, for an excellent job. I wanted to thank the Agro-Webinar Committee and the ISAA Agrochemical Network for the start of a great collaboration between the two organizations. I'm very proud to bring the two organizations together. You may be asked to complete a follow-up survey after the webinar, and we very much look forward to your feedback on this webinar and the lineup that we have in 2021. So thank you all for your attention, and we'll see you next time. Bonsoir.
Thank you. Bye-bye.